we can start now. Sir. So, Bardhan sir, please come to the stage. One more thing. Actually, this is a 45-minute show, but madam has strictly told me to conclude it in 20 minutes. So, we will go accordingly. Okay. We will try to conclude in 20 minutes. So, I will try to reduce my dialogues. Okay, Bardhan sir, you just come here and you can see a lot of food items here. Can I have a mic to give to Bardhan sir? You just see the food items and what all food items are seeing.
Yeah, I think sugar solution you
sugar
are
is there.
keeping, and dal. This
Dal
is
is
actually
there. Then
this is the dur dal, you know?
dal.
Dal, and then this is tea.
Tea.
Okay.
Then
And then papaya. Yeah.
papaya seed
Papaya
is
seeds.
reading the levels.
Okay. Oh, I
This
can
is,
see. No?
okay, you can see.
I can see. Chalk
I
powder.
added salt.
Then this is a brick powder.
Not brick powder.
Acha.
Chili powder.
Oh, chili powder. Okay. Then volunteer, you have to educate him.
Okay. Anyway, thank you, sir. Thank you so much. actually, it is written chili powder plus brick powder.
Oh,
Okay. So, we'll move to the show. So, Bardhan sir has read out some food items here. So, you will be getting some idea about what will be my show. Food adulteration. So, it is a very crucial topic in today's society, food adulteration. So, we'll try to find out what are the adulterants present in the daily food items. Actually, this show, we have prepared in such a way that even a small child in his house can test the what or adulterants are present in his daily food items. So, actually I am coming from Kerala and I can see Rajichi there. She was working there for years. Rajichi, please come to the stage. For simply doing one experiment, come. So, I am giving Rajichi a little powder. You just put this powder into this. You just put this powder. Smaller? You do. Slowly you do. Okay, some more. Okay. Now, Rajiji, you can see some powder is floating and some is sinking down. You can see now. Actually, this is coffee powder. So, can you say here adulterant is actually chicory powder. So, any guess whether the sinking one is chicory powder or the floating one is chicory powder? This is actually the branded coffee powder. So, there is chicory in it and one powder is sinking down and one is at the top. Any guess which is the coffee powder and which is the chicory powder? Bottom, yes. So, can we have a clap, Rajichi? Chicory will be sinking to the bottom. Thank you. And coffee powder will be at the top. So, this is a very simple method to find out the chicory powder in coffee. So, always coffee will be at the top and chicory will sink down. Actually, this chicory is added to increase the bulk and to make profit. If it is only coffee powder, it will be at the top only. Can I have that presentation? Okay, so we have already told. So about food adulteration. Next one. This is what we have seen. Next one. Okay, so next one. And this chicory powder actually it is very harmful. It can cause serious stomach disorders and severe joint pains. Now I have another 2 glasses of water. Yogesh, please come. Vishalji, please come. You do one thing. You take this sample and add a little sample to this beaker. Vishalji, I will give you. Nothing, you just pour little. Bas. Vishalji, now you can try this one. Honey. Both are samples of honey. Okay. So you can see the difference. One is getting disposed and one is without dispersing at the bottom. So the first one which Yogesh has poured is being at the bottom, and other is getting dispersed. When Bishwalji is adding it this is dispersing like this, and the one which Yogesh already, it is at the bottom only. So this is pure honey, and the one which get dispersed is adulterated honey. We have adulterated it with sugar. Okay. Sugar can be added as the adulterant. Thank you. Now Rajesh ji, can you come to the stage? No, this is a magnet. You can play with this. Okay. So I will give you a powder. Please show them whether it is pure or not. Any powder is there? Nothing is there, no. Magnet. Okay, no. Now you just wave this magnet through that red color. Okay. You see? This is actually tea powder. So this often happens in tea. This iron powder will be mixed to increase the weight. So it happens. So a small child also can do it. Okay. So it happens. Thank you. Next one. In coffee also it happens. Next one. Previous one. So now I can call Ponnareshan sir. Your presentation is next one. No, you stay there. Madam, can you come? So we have only 20 minutes, so I am trying to complete it. Madam, actually, here I have a solution.
Yes.
And I have some pepper here. You try to put this pepper in the solution one by one.
One by one.
Don't be so cautious, you can put. Some more speed. Our time is less, only 20 minutes. Okay. So she is adding, some are floating, some are sinking. You can add, completely you can add. Completely you can add. Okay, thank you, madam. So, any guess about this? Actually, this is pepper. Pepper I have. Very good. Give her a clap. This is papaya seed. Actually, this is isopropyl alcohol solution. So, we can easily test the papaya seed from this black pepper. Actually, this papaya seeds, we collected it. This is rainy season, so rainy season no. So our train is collected it. So I am saying a big thank you to them. In this rainy season, they collected it and dried and give it to me. So these are all pepper, and this is papaya seed only, and it causes serious, severe joint pains. So it is very dangerous. Can you move to next slide? Next. I already told that. Next. Okay, now I have some. Bharadhan sir has already given, suspense has been broken. So I have, sir, you come. Now, how much is the time? No, ma'am, that much things only. Don't worry. Now I have taken less than 10 minutes now. I will conclude. Okay, sir, you add some powder to this and try to stir it and dissolve it. Dissolve it. Now dissolve it. Dissolve it. So actually, as Bharadhan sir told, there is brick powder in it. Actually, it was chili powder. There is brick powder in it, and there will be sedimentation and there will be color change. Okay, so brick powder is added, This I have added actually, so this happens in our daily life. So we have to be very careful. Okay, thank you, sir. Sir, can you come to the stage? Everybody has to be visible, so I am keeping this a little front. I hope our camera is there now, so everybody can see. So I have 2 samples of milk. You just take that dropper. Come here, come here. You just take that dropper and add a drop here to. You just give a drop. Slowly you give a drop. Okay, okay, it's okay, it's okay. Next one you take it little more and try. Okay, now let's see what is happening.
The second one.
Actually, this experiment is a little bit failure. I will explain you. The thing is that this is real milk. It will stay back there, but when it is adulterated with water, it has to go fast. But it has not happened because for the next experiment I have added the detergent powder already. So because of the detergent powder, it is staying there. Otherwise this will stay there and it will go very fast. So in hurry we have added the detergent powder. For the next experiment I have taken that sample. Hope it is clear. Then next one is this, you can see. Sir, you just stir it. You just stir it. And I am stirring it. This is plain milk only, so it will not form any lather. And that one actually, it is detergent added, so it will be more creamier and foam will be formed.
Foam is formed.
Actually, this we have added some detergent powder. So very often this milk is adulterated with water and also detergent powder. Okay, thank you, sir. Next. Next slide. Here also, actually, we have some sugar. So we can see very turbid solution. Actually, it is adulterated with chalk powder. So it will not get completely dissolved also. So it is already adulterated with chalk powder. Then we have this apple with me. Rageshji, can you come to the stage? And I'm not giving you this apple to eat. You have to scratch it and try to get some wax from it. If you scratch like this, you can get some wax. This will be more. So I will show you. You just put that wax. So Rageshji is getting wax from. Okay, enough. So it is wax coated actually. Many often in our markets, these apples are coated with wax for getting shining and appearance. Then I have some samples. This is actually pure sample of dal. And how to find out the extraneous matter? You have to just look at the compare these 2 samples and we can see the difference. This is pure one and this is loaded with extraneous matter. That can be visibly we can understand. Then actually here we can see green peas. This is pure green peas actually. You can see, and there is a chemical called malachite green. If we add a drop of malachite green and mix it well, we will get some colorful piece like this. This is a little over actually. I added a little more. So malachite greens are often added to this green peas, these green chilies, etc., to increase the color, and it is very dangerous for our health also. Next. So we can test it either by adding some water or with the help of a cotton also. Next. But we can test these green vegetables like this with the help of a cotton and by rubbing it. We'll see the color. Next. Next. This I already told. We have find out the extraneous matter. Then next one. Next one. This is rhodamin B. Okay. This is having very interesting color now outside. So let us check. We can see the pink color. It is very often happening in our markets. Okay, next one. And it is very dangerous. It causes very diseases to our kidney, liver, etc. Next. This already I have done like that. This our sugar, salt is also adulterated with many white powders. So cheating is very easy in this white color. Next. Next. This you can see actually this rhodamin B, this ragi, they often adulterate it with this pink colored rhodamin B. So if we add little water, we can see the clear separation. Next. Okay, so since we have to carry these items and we have to do this experiments in a very little time, I have reduced my dialogues and all. So thing is that in our daily life, I have taken only 15 items. This is not the case. In our daily life, we are using many preserved food items also. Lot of chemicals are being used. In fish also, chemicals are being used. So we have to be very careful actually. Government laws has to be strict. We have to read the labels. Then we, in our home itself, we can find out the chemicals present in these food items with this simple experiments also. Thank you all.
Thank you, Binod sir, for bringing the food adulteration topic, which is also very important to discuss among us, right? So also for sticking to the time, understanding the time. For our next presentation, we have Mr. Ponnarasan from District Science Center, Gulbarga. His topic will be on cardiovascular system. Welcome, sir.
ಮ್ಯೂಟ್ ಮಾಡಿ ಓಕೆ ಇದೆಲ್ಲ ತಗೊಂಡು ಬನ್ನಿ. So good evening to all of you. So myself Ponarasan from District Science Center Gulbarga. So first of all, I would like to welcome you on this special occasion. So I am going to perform on science show on heart in action, exploring the wonders of the cardiovascular system. Cardiovascular system, why I have selected this topic? So 2 months back in the District Science Center Gulbarga, we have inaugurated a new gallery on the incredible human body. So there we came to know that students are facing a lot of difficulties as to understand the heart and its function. So here I have made one working model. As we know that it's very difficult to make a working model in the field of bioscience. So here I have made by using a syringe and some tube. So here indicates different colors, blue color and red color. So before that I want to say something about heart. What is the shape of heart? Where it presents? Have you ever seen your heart? Have you seen ever your heart? Where it is? So that is present in our chest region, in the mediastinum, in between two lungs. What is the shape of your heart? Simply we can say, no, it's not like that. So heart is a cone shape. And what is the size of your heart? So your fist. So irrelevant to your weight of your body, sometimes more than 100 kilograms you may be there. But the heart structure, the size is your closed fist. So this is a structure of heart. And if someone asking you, will you give me a place in your heart for staying? What would be the reply? Or else, so see, so nowadays, so we can compare. We can consider the heart is a, what is that? Okay. It's a emotional feelings. It's a symbol of love. You know, we are using heart so for symbol of love. Why? Why we are using heart for symbol of love? So because connected to the emotion, the feelings of emotion. So when you excited, check your heartbeat. When you being sad, you check your heartbeat. Simply we can say, without knowing, surprisingly, if you get a promotion order, check your heartbeat. If you get memo, check your heartbeat. Definitely there will be a difference. So, in a normal adult human being, the heart rate is nearly 72 times per minute. 72 times per minute. How many chambers of heart? How many chambers? 4 chambers. 2 upper auricle, 2 ventricle. So really heart is a hollow muscular organ. It is covered with a membrane that is pericardium. And muscle, it has 3 types of muscles. Inner pericardium, middle and outer pericardium. So in between 2 membranes, so there is a space that is filled with a fluid, that is pericardial fluid. And the blood vessels, when you talk about the blood vessels, there are 3 blood vessels are there. One is arteries. See, so the blue color indicates, so these are veins actually, veins. And red colors are indicating, so that is arteries. See, arteries are always carrying deoxygenated blood, except only one artery, which is that pulmonary artery. So it arising from the right ventricle. And veins always it's carrying arteries are always carrying oxygenated blood, veins are carrying deoxygenated blood, except only one, that is pulmonary artery and pulmonary vein. So that is bringing blood from lungs to left auricle actually. So there are two different types of circulation. One is systemic circulation and one more is pulmonary circulation. So pulmonary means lungs. So heart to lungs. So this pathway indicates the deoxygenated blood from right ventricle to lungs. So why it's carrying blood towards the lungs? For getting oxygen. And again taking oxygen from the lungs, it carries the blood towards the left auricle. So from left auricle to, it goes to the left ventricle. So left ventricle receives the blood from left auricle through a, what is that? Next I am talking about the valves. Do you know what is mean by valves? So there are three types of valves are there. So one valve, that is tricuspid valve from in between right auricle and right ventricle. So tricuspid means they have three flap-like structures. They are allowing blood flow from one direction. So it controls the reverse blood flow from right ventricle to right auricle. See, so these are the valves actually. See, so these are a tricuspid valve. So there are three flap-like structures. So these tricuspid valves are connected with the inner wall of heart with the help of tendinae, that is chordotendinae. So which give full support to the what is that? Full support to the valves to control the backflow of blood. See, this is a picture of 1 minute. Actually, so see the valves actually. So this is tricuspid valve. This is bicuspid valve or mitral valve. So these tendinae, so these are chordotendinae. It gives full support to the valves. So to prevent the backflow of blood. So these are semilunar valves. Semilunar valves present in the aorta as well as in the pulmonary artery. So this is a circulation actually. Already I told you there are two different types of circulation: systemic circulation and pulmonary circulation. So apart from that, two more circulations are there. That is portal circulation. Sorry. So this is a portal circulation. So portal circulation means the oxygenated blood or nutrient-rich blood, so going to the liver, so to remove the waste materials, and finally it will empty it into the normal blood flow. So next is composition of blood actually. So what please? What? Okay, thank you. In the composition of blood, there are two different parts. So one is liquid part and another one is solid part actually. So liquid part consists, that is plasma. So plasma makes 55% of volume of blood. Plasma. So it contains nutrients actually, hormones, what is that, albumin, fibrinogen and water, salt nutrients. So they are present in the plasma. And blood cells. So blood cells are from three different types, that is erythrocytes, so otherwise known as the RBC cells, then leukocytes, that is WBC cells, and platelets. So they are calling a clotting factor. So RBC cells, otherwise known as the red blood corpuscles, what is the major function of RBC cells? Carrying oxygen and supplying towards all the parts of the body, and the color of RBC cells is red color. So what is the reason behind that? So presence of hemoglobin. So hemoglobin is a color pigment, so which helps to combine with the oxygen, then it will convert into oxyhemoglobin, and again while it goes to lungs, then it will convert it into carbaminohemoglobin. Then after it will, so this is a gaseous exchange, okay. And then leukocytes, so these are the types of leukocytes, otherwise known as blood RBC cells, sorry, WBC cells. WBC cells are nucleated, but RBC cells are anucleated. So this is the RBC cells biconcave. WBC cells are RBC cells are biconcave in nature. It is very elastic in nature. So these WBC cells are two different types are there. That is 1 minute. So granulocytes and agranulocytes. So granulocytes means granules are present in their cytoplasm, and neutrophil, eosinophil, and basophil. So these three things are called granulocytes, and agranulocytes are monocytes and lymphocytes. So major function of neutrophil, so that is phagocytosis are the bacteria. So mostly it gives a protection from the invading microorganisms, and eosinophils are controlling, so the allergic condition, whenever you are getting allergic condition, and that time, so it goes to the particular organ and control the allergic conditions. And next basophil. So basophils are, so these are the structure actually. This is eosinophil, so neutrophil. So this is eosinophil, and this is basophil. So three lobed structure nucleus, and eosinophils are bilobed nucleus structure, and this is basophil. So main function of basophil is secretion of histamine. Actually histamine or heparin. So these are called as anticoagulant agents. So anticoagulation agents means, so you should not secrete in the intact blood vessels. When you get any injury, so then only heparin, not heparin, that is thrombocytes will activate. So thrombocytes are nothing but blood platelets. So this is the structure of blood platelets actually. In the number of RBC cells actually, number of RBC cells 1 cubic millimeter of blood. So it consists of nearly 5 millions of RBC cells. WBC cells, the same quantity, but number of WBC cells are nearly 8,000. But in the, what is that? Platelets are nearly 2 lakhs to 5 lakhs. So per cubic millimeter of blood. And thrombocytes are disintegrate. When you get any damage in the blood vessels, thrombocytes are disintegrate into thromboplastin. So thromboplastin is what is that? These are triggering. So next I will show you the so process of blood clotting actually. So clotting factor. So the prothrombin is converted into thrombin. Prothrombin is an inactivate enzyme. So when it will get activated, so whenever if you get any damage in your blood vessels, the clotting factor initiated prothrombin into thrombin. So these thrombins are active enzymes. So these active enzymes are the soluble fibro, converting the soluble fibrogen into insoluble fibrin. So fibrin is nothing but it is a network-like structures and cover up the bloodstream and controlling the bleeding. Okay. Then blood pressure. So what is blood pressure? The force which is exerted, in the walls of blood vessels during the blood circulation. See, here atrium, this is the artery and aorta. And that time the walls of arteries they are getting pressure. So that is blood pressure. The normal adult, so the blood pressure is 120 by 80 mm Hg, 120 by 80. If it goes beyond that, that is hypertension. Then if it comes low, that is hypotension. Then heart sound actually. So what is your heart sound? So we can observe the heart sound by using stethoscopes. Lup tup. So lup, it is a longer sound. Dup is a very short period sound. So lup sound. So it's hearing at the beginning of contraction of ventricle. You see, the beginning of a contraction of ventricle, it pushes the blood towards the pulmonary artery. At the same time, in the left ventricle, it pushes the blood towards the aorta. So at the same time, the tricuspid valve and mitral valves are closing violently. So that sound is hearing lup sound. And at the same time, in the relaxation, at the end of the ventricular contraction, so that is the closing of mitral valves. So that creating dup sound, lup and dup sound. See, one more thing, if the valves are not closing properly, so that leads to valve stenosis. So that creates some sound, that is heart murmuring. The cardiologist can hear the sound, so they can able to identify. Then pacemaker. Actually, our heart has an electrical conduction system. Electrical conduction system. So where it starts, the heartbeat, lup tup sound, it start from sinoatrial node. Where it is? Sinoatrial node, here it is. Sinoatrial node, sinoventricular node. Again, the electrical signal conducted towards the ventricular muscles. So this is a natural pacemaker. Natural pacemaker is known as sinoatricular node. And last, I am going to tell you something about blood grouping actually. So what is your blood group? O positive, AB positive. O positives are you are calling as universal donor. AB groups are universal recipient. See, here I am going to check my blood group within 1 minute. See, no, sir, I will do for myself. See, in the A group persons, they have A antigen in their RBC cells. A group persons, they have A antigen in their RBC cells, but B antibodies in their plasma. But B group persons, they have beat.
Thank you, sir, for the session on cardiovascular system. Especially yesterday, we spoke about challenges in bringing biology to demonstrations. Right, this kind of working models actually would really be very relevant in the science demonstrations. Okay, so for the next session, we have Mr. Kandavel Raja, who is an education assistant at Regional Science Center, Tirupati. His session would be on nanoscience. Welcome, Mr. Kandavel Raja.
You just.
இது நல்லா இருந்துச்சா ஆல்ரெடி செஞ்சு வச்சது ஒன்று black chart. Okay, sir. Okay, let's. Okay, let's start. Okay, good afternoon, good evening. So, first of all, I am thanking you for giving me the opportunity. So now, I am going to conduct a science show on nanoscience. So, some of you may already know about this nanoscience, but this nanoscience is somewhat the experiment will happen in very nano level. It is not visible to our normal eyes. So I'm going to do some experiments that is somewhat analogy to the nanoscience experiments. Some will be related to the application of nanoscience. So I tried to make you understand the concept. So that is the main aim of this science show. So before knowing about nanoscience, I want to tell you that in science, whenever we want to learn a concept, first we have to imagine the concept. Our imagination is the main thing. So whoever start learning science, first they have to imagine the concept. So Einstein has already told, imagination is the main thing for learning science. So here also we are going to give some examples. So at that time you have to imagine, so then only you get the concept clearly. So for example, whenever I am telling about pressure, so we all know about the formula, pressure is equal to F by A, or else P is equal to force by area. But if I say in this physical terms, it will be somewhat raw in nature, whereas I can give you an example that we can consider one rat is here. If one elephant try to stand over it, what will happen? So immediately you got the imagination, then you can see. So here what happened, area reduced, whereas force is high. So because of that, pressure is increased. So like that, here also whenever I am telling some analogies and experiments, you have to imagine the things. Okay. So now we are going to see about nanoscience. So what is mean by nano? So nano is nothing but scale down experiments or scale down things happening in the nano level. So normally you can see we used to measure things in meter and kilometer. So the thing is, here you can see, here we have 1 meter scale. So in this 1 meter scale, we will have 100 centimeter. If we try to divide this to 100 crores times, so in this level, we will get the nano level. So it is very small scale. It is not easily to imaginable one. So try to assume that one. Okay. So normally you can see, if we take any material that will have atoms and molecules, everything is present. So we are going to do experiment in this nano level. So actually it is nanoscale science. It's an interdisciplinary concept. We are dealing with technology and engineering and science. We are going to apply these things. So it is an interdisciplinary concept. Okay. So first, to understand this concept, normally we can see, here we have 2 glass. So normally if we take water on this glass, we all know, if you take water on this glass, if you try to turn it down, what will happen? Due to gravity, it will fall down. So that we all know. Whereas if we reduce the scale to somewhat less, here this water will fall due to gravity. Whereas is it possible to overpass the gravity? So to do that, here we have one small scale okay. So this is somewhat bigger one. I got another one. We will try. So for color variation, I have had food color. Oh, here it is. So actually I have bring 2 small glasses for here to see the difference. So now we are going to add water here in these 2 smalls. So to see the difference, we have added here red color food coloring agents. So are you able to see the water inside this? Okay. So now you can see, we try to upside it down. So here you can see, so this is somewhat bigger in nature, this is somewhat smaller in nature, the diameter is. So here you can see the water is not falling down. So here after sometimes it will fall, you can see it's fall down because the radius is somewhat bigger one. So here when we try to hit this, slowly you can see the water is coming down. So here, even though gravity is working here, why it is not falling down? Surface tension. So here we can see we have make the capillary reaction is also there. Here we have scaled down, and because of that what happened? We have surpassed the gravity. So like that, this experiment most of you already know. We have a glass. So in this glass, I have added a mesh. So normally, due to gravity, it will fall down. But if we close it tightly, and when we try to hold it, because of the mesh is having small holes, the surface tension here add up together and hold the water. So you can see this is happening in macro level itself, it is happening here. Whereas if we try to do these experiments in a nano level, you can assume that we can achieve wonders using this nano science. Okay. So now the next experiment, I am going to take water in 2 glasses. So here what we are going to do is, we are going to use antacid tablets, one in powder form, one in normal one. So the thing is, both are same tablets, but the difference is one in tablet form, one in powder form. So because of that, what will happen? Okay, I am going to put both of them same together. So you can see the difference. The powder one is becoming fizzing out. So because of that, both are having the same volume, and you can see surface contact. The tablet is normal water remains same, whereas the powder form is having more ratio, more possibility to contact with water. Because of that, it is fizzing out. So like that, if we reduce the surface, if you increase the surface area, so because of that, we can increase the contact area, thereby we can do the nanoscale experiments. So that normally if things behave in a normal way, they will behave entirely different. So for example, we are taking coke in aluminum containers. If we take the aluminum powder form, or it is nano level, it will become an explosive one. So whereas we are using it in a normal scale level as a coke cans. So like that, if we change the property at nano level, the things will start behaving differently. So here we have one liquid. So it is somewhat white color in nature. Anyone of you can guess me the liquid? Okay. So it's a, I will tell you what is the liquid later. So now what we are going to do is, so it's very liquid in nature. Now here we have one egg. So what we are going to do is, we are going to place this egg inside this liquid. So once we place inside this liquid, so the close. So we have placed the egg inside this liquid. Now what we are going to do is, we are going to drop this liquid from 5 feet height. If we drop from 5 feet height, what will happen? So it is very liquid in nature, you can see, very liquid in nature. If we drop from this much height, what will happen? Egg will, due to its fragile nature, it will crack and it will damage. So let's see what will happen. Now you can drop. Now you can drop some. Okay, then you can reduce. So you can try as many times possible. You can take the egg outside. So this egg won't get damaged because this liquid is a non-Newtonian liquid, non-Newtonian fluid. So normally water and some Newtonian fluids will react normally, the egg will get damaged. But here this non-Newtonian fluid is nothing but cornstarch. The cornstarch we are using in our day-to-day life for in our daily basis. So we are mixing with water, because of that it is becoming a non-Newtonian fluid. So non-Newtonian fluid is nothing but if you try to hit harder, as much as pressure if you are trying to give, it will act as a solid. If we deal with it very slowly, it will become liquid. So that is the nature of non-Newtonian fluid. So using this non-Newtonian fluid, we have safeguarded this egg. So what is the use in nanoscience using this non-Newtonian fluid? So scientists have developed shear thickening fluid, STF. So that fluid will act as like this non-Newtonian fluid, whereas this is made using an organic material. Because of that, after sometimes it will get damaged. So whereas it will get decay. Whereas when we make an artificial material using this shear thickening fluid, so using that we can make a protective gears or protective jackets. So by using that we can safeguard our lives. So whenever any material hit on our body, of any accident happen, we can safeguard from the severe crush. So this is already developed. Some even made some hat using this shear thickening fluid. So using that hat we can sustain in the cool environment also. So harsh climate we can manage using this shear thickening fluid. So this is an example of non-Newtonian fluid. So now we are going to do an experiment using nail polish. So the nail polish is a simple experiment. Just we have to take water in a plate. So once we take water in the plate, we got a black chart paper. So what we are going to do is we are going to place the paper on the water. Okay. So now what we are going to do is we have gotten a transparent nail polish. So using this nail polish, we are going to make some drops over the water. So once we made drop, what will happen? If we drop nail polish over water, what will happen? And thin film will form over the water. Okay. So this is an acetone. So when we drop this water, nail polish on the water, because of surface tension, it will spread over it. So once it dried out, you will get this type of film. Okay. So it's somewhat in rainbowish nature. This is because this thin film interference is formed here. This is in somewhat few hundred nanometers level. So actually when light fall on it, the light where the thickness is there what will happen? The light will get fall on it and it is reflected back. So thickness where it's high, because of that the color changes is happening here. So here we have seen a nano level thin film interference here. Okay. Thin film interference. Nail polish. Paper is black chart only. If you use white paper, you won't see the color, because the light has to be reflected back. Okay. Okay. So now here we have one box. I need one volunteer to do this experiment. So this is somewhat puzzle in nature. The main thing is here we have 9 cubes. If we have 9 cubes, means in each side we will have some images. So by seeing this you can assume. So you can try to arrange any one of the image. So since time is less, I can tell you the answer directly. if we try to assemble the image, we will get 2 images on both sides, but remaining 4 images will hidden inside. So when we try to open it out, you can see the remaining images. So like that, when we try to changing it again and again, you can get different images. So because of that, you can understand, when we increase the surface area, the more we will get contact. Whereas the volume remains same, but if we increase the area, because of that, we can do the nano things. So in nano level, mainly we are increasing the area, or we are doing the things in nano level. When we are doing coating at nano level, we can change the effect easily. Okay. So in the ghee coat, green color. Is okay. So here we have 2 application of nano thing. So this is look like a normal sand, but this is kinetic sand. So kinetic sand is nothing but look like a normal sand, but you can see it is stuck inside. After some times, you can see slowly it will come down. So it was somewhat look like moisture absorbed sand, but you can see when we take it in our hand, it won't get absorb the moisture. So any one of you, please come to the stage. So try to fill the kinetic sand in this material. So you can see it look like somewhat moisture absorbed sand, but when we try to form shapes using this kinetic sand, once we take it out, you can see there will be no trace on this material. So this is an example of nano coated material. So it is coated with polydimethylene siloxane. So this material, you can see it form the shape here, but when we take it out, again it will get attracted. So at nano level, that coating has been done. Because of that, this will get attracted to each sand molecules, sand particles. So because of that, again and again we can use as many times as possible. So like that, there is a hydrophobic sand is there. So when we place it inside water, it won't get absorb the water. When we take it outside, again it will behave normally. So here I got 2 cloth. So by visibly seeing this, you can see it is very normal in nature. But here I have made one as a nano cloth. So by visibly seeing this, are you able to identify? No. So now here we have the water bucket. We are going to place both inside this water. You can see which one is nano coated, the left one. So you can see even the small water droplets that is sitting on the cloth is coming out, whereas this one is very water has been absorbed by this cloth. So you can see the difference. So this is just spray is available. We can use this type of nano coating. We can apply in our day-to-day equipments if you want to save from water any problem if occur when we go in outside. For example, people used to spray this on shoes and cloths and raincoats. Like that, we can use that. So like that, in our day-to-day life, we used to have some different materials we are applying in our day-to-day life. Anyone of you know, in our practical life, we are using one material. Sunscreen. Sunscreen is actually nano-coated one nowadays what you are getting from markets. So previously when we get sunscreen, you will see some white coating will seen in your eyes. But nowadays the material available with nano-coated material. So the zinc oxide, the same material they are using, but at a nano level. Because of that, it will become more transparent in nature. So that is why even though we are applying the sunscreen, but it is very transparent in nature. So the last one, if we have an example, I need a volunteer for this. So this is a simple example to explain this experiment. Since it is happening at nano level, so dealing with these things, it's very difficult for us to measure the things and coating the nano material over it. So for that, to go give an example, please come here. So you try to pull these blocks. So at normal hand level, you can easily take the blocks out. So you can try to fit all the blocks. Oh, yes. So once we connected, since at a hand level, it is made for our normal hand level, so we can use it easily. Here we have some oven mittens. So now what we have to do is, you have to wear the oven mitten. First you have to wear using your thumb inside this. Okay. So both hands you can place it. So the main thing is, it's just a simple experiment, but you can see science is nothing but a trial and error. So whenever we are doing a trial and error, here you can see what you have to do is you have to now connect these blocks using this oven meter. Okay. Okay, I will take it out. I will. Okay. So you can see. So now using his thumb is inside this. They have given some separate this for thumb. So because of that, somewhat he is able to do, because thumb is having separate one. But now you try to connect. You can do it, but somewhat harder, but we can do it. Okay. Yes. Now the next level is he has to take the thumb inside this one. So all the fingers should go inside. Okay. Okay. So now try to fit this. So because of that, you can see it's very harder for us to do this. So like that, there is a scanning probe microscope. Using that, we are sensing the nano level material and detecting what is happening there, and do the experiments there. So like that. So now you can see just changing our finger size. Because of that, we are unable to do this experiment. It's a very easy one, whereas we are unable to do. So like that, in nano level, so many things are happening. So this nano science is an interesting one. In our day-to-day life, we are facing so many challenges. So we want to change our life and upgrade. So the main thing of learning science and scientists are doing research is to improve our day-to-day life. Day by day, we are becoming more and more efficient, but our workload is getting decreased. So that is the main aim of inventions and science experiments. So like that, in our day-to-day life, we have to try to apply science in our day-to-day life so that we can become a more efficient one. So one more thing I want to conclude here. So whenever we try to study about science, so we should have a curiosity like Buddha. So Buddha, when tried to attain the enlightenment, what he said? He tried to find what is the reason for sorrow. So he roamed so many days, and at that stage, one point he got the enlightenment. So like that, when we try to find or study different concepts, at certain stage we will start connecting, or we are able to know about the interdisciplinary connections. So day by day, we will become more efficient. Okay. Thank you all.
Thank you, Kandavel Raju, for taking us into the nano world. And for the last session of the day, we have Ms. Sangeeta Ray from NCSM. She's
राजर्षि भट्टाचार्य जी, राजर्षि भट्टाचार्य जी, चंदा मामा, हाँ हाँ नॉर्थ ईस्ट जोन, नेशनल साइंस सेंटर गुवाहाटी.
So for the last session of the day, we have Mr. Rajshri Bhattacharya from NSC Guwahati. His topic would be Chandamama. Let's see what it is. Welcome, sir.
Just a moment, give me. Three times actually I have tried. Suddenly has changed this machine. सामान नीचे पड़ा है. सर सर हाँ बोर्ड चाहिए इसलिए लिए. Yes, yes, yes. I brought it. Which one? Okay. No.
Sir, board view, that board must be there.
Okay.
ಇಲ್ಲಿ ಇಡಲಮ್ಮ ಆ ಬೋರ್ಡ್ ಇಲ್ಲಿ ಇಡಬಹುದಾ he wanted means this is actually ideal place, then only camera is come within the camera.
Okay, no problem.
ಇದು ಕ್ಯಾಮೆರಾ ಎಲ್ಲ ಬರಬೇಕು ಇನ್ನ ಶಿಫ್ಟ್ ಮಾಡ್ಬೇಕಾ
আচ্ছা দিন ওই মাটিটা দিন এই যে
সিমেট্রিক্যালি ಇದೆ ಅದು
কোথায় হ্যাঁ হ্যাঁ ওইটা হ্যাঁ স্যার দিন স্যার ওটা না লাগলেও হবে
ಸರ್ ಇದು ಬಂತಾ ಇದು ಬಂತಾ
Hello. Good evening to all of you. So, I have a very strange topic. You know that Chanda Mama means it's about moon, but I shall not discuss that rudimentary facts about the moon that we all know that. But still, I shall try to keep pace with the time. And we have learned so many things about moon that today these are all important. But still, first of all, let me introduce myself. Myself, Rajarshi Bhattacharjee. I am coming from National Science Center, Guwahati, and we are from representing Northeast Zone. And this is a map of our zone. So, Earth's moon is the perfect shape, size, density, distance from us to produce this stable environment that is important for life to thrive. That is my first, because if there was no moon, we may not be there. So, how this moon, formation of this moon is very important. As on date, there were so many theories. So, as on date, there is a great impact theory that is the most acknowledged theory that explains all the thing, that one Theia or Theia kind of thing, like a Mars-like planet impacted with our nascent Earth, and then some debris coming out from there, they get together and forms moon, and then slowly that moon, earlier that moon was very close to us, and slowly it got a distance that is very stable distance. Now it is slowly moving to outward, actually outward, but this movement is now very slow. So the first question come to my mind is why moon does not fall on us. The very first question. But let me launch the moon. Yes, that sometime fails. That is primordial moon. So maybe see, this moon is not coming down at all. Though it is not the real reason, but still it is not coming down. Say, it is slowly coming down, and I am compensating that downward movement, and it keeps on moving. So my first experiment is a participatory one. I cannot resist myself. that is the asymmetric character of that moon, that far side, because I have given the name that it is the rear side of the moon. But hardly I can discuss because this cause is really not known to the scientist even. Because why this kind of asymmetry between the near side or far side? But moons of solar system, other moons of solar system, we know Jupiter, Saturn have their moons, an array of moons. But today, as on date, there are 891 moons of solar system, declared moon. They are maybe in the form of asteroid. Even some asteroids have moon. So this is the another strange phenomena that we experience. But I need this table to be removed. Actually, we have a participatory session. Just a moment. Okay. Rajesh, maybe absent. Rajesh, you may be always there. So, Rajesh will be my moon.
Wow. I'm Chanda Mama today.
And he will be holding that stick towards me like that. Okay. Same. Myself be the earth. Tell them to now start circling me. I shall also facing you. He is always facing me, but direction is changing. Direction is changing.
Right. Now it is backside towards them.
Towards them.
Yeah.
But it should not be that. Like that. But I am the earth, not they. Let's start. Okay. Okay. Start. I have trapped you. I already have trapped you. Because you have a spin orbital resonance with me. It is known as tidal locking. So, you are tidally locked. Thank you very much. We always see the same face of the moon. Where is my? That's the thing. That is how he was moving around me. Now, it's a memory game. No moon map. That's why this board is required. First, you see. Let me write down 2 or 3 names from here. This is another prominent northern hemisphere moon that we used to see. Okay. Where is that? C of So, in the next map I am going to show you, I have written down 2 names. That first one is the Sea of Tranquility. This is the first moon landing location. So, in my next, I have inverted this moon. Actually, this is the moon that our Australian friends used to see. So, for them, someone has to identify these 2 locations over here. You have seen, no? I have given you more than 30 seconds. Okay, okay. That is Sea of Tranquility. This is Sea of Tranquility, okay? Whatever, whatever. Let us check. Let us check. he has rightly pointed out that these two are. So let us do some fun game. I need 2 volunteers actually. आ जाइए आप लोग सुबह से. He will be holding that art. It is almost 20 inch say, and he will be choosing. I am having 3 moons with me. The best fit moon you have to choose. But this, it is around 18 inch. 18 inch. So what is the best fit moon for this?
1/4 of the diameter, 1/6, 1/8.
It is actually actual diameter of Earth is 13,000 kilometer almost.
How much the diameter?
It is 18 inch. I have given you 18 inch. It is more than maybe 18 inch, 20 inch like that.
So 3-inch diameter. I need to take.
Or 3 inch. You are seeing. Rajesh ji, Rakesh ji, जल्दी खत्म करना है.
1/6 na, 1/6 of the size.
1/6 is the gravity. It is not the diameter ratio.
1/4, 1/4.
Best fit.
So this one.
Okay. He rightly choose the right moon. Okay. Now the distance. Now you have to go back. So it is say 1.5 feet. So what is the distance?
3,84,000.
Oh, you know that. It is quite clear. So you have to go back around 30 times. This. Because it is 13,000 and you have to cover 3,84,000. Ah, so okay, no problem. You go. Behind camera, you take the straight line. It is 1.5 feet. So you have to go 30 times, almost 45 feet. Keep going, keep going. You know, how long is this hall? I think it is not 45, less than 45. This hall? Ah. Less than 45, I think. Because that time I measured that it is around 40, 42 feet like. You have to keep going, keep going. So, actual distance दोनों का distance ज़्यादा हो गया.
मून नहीं दिख रहा है मेरा.
मून नहीं दिख रहा है लेकिन फिर भी मून आपके साथ ही है. आ जाइए. बहुत दूर जाना पड़ेगा. मतलब आपको 30 टाइम्स एटलीस्ट जाना पड़ेगा. चलिए आइए. आ जाइए. तो ये रूम भी अकोमोडेट नहीं कर पाया इस स्केल में. मतलब ये अगर 1.5 फुट होगा तो इफ इट इज अराउंड 18 इंच देन यू विल हैव टू गो एटलीस्ट 45 फीट. सो दिस रूम could not accommodate the moon distance between earth and moon, this earth and moon together. Okay, thank you. These are some rudimentary facts that moon is, the disk of the moon is around 3,500 kilometer and disk of that sun is 400 times larger than that. Still, it is occulting moon occasionally. Let us do that exercise again. I am having 3 moons with me. One is around 4 inch, one is around 3 inch, one is around 2 inch. Which one is going to occult this one? That full disk. From a small distance, because it is in a small distance compared to sun, so I have to place it just before the projector. But which one? I don't think so, because the projector is that way. Okay. So this is 3 inch, almost 3 inch. If I It is closer. So it is totally occulting that sun. Okay. Thank you. So I myself act as a volunteer. So size distance approximation we have done. Now phases of the moon. Phases of the moon, you will always have the phases of the moon in a different way, but I am showing it in a different way. But I at least need 2 volunteers. That sunlight coming from that side, rather coming from that side. I shall hold. You have to be inside as an earth. Sir, see, slowly anti-clockwise you move. Slowly anti-clockwise towards me. Crescent, then first quarter, then waxing gibbous, then full moon, then waning phase, third quarter, then waning crescent, then new moon. That moon does goes on and goes on and on. It's a new form, I thought. That's why initially I thought that I'll show with a ball like that, it will rotate. But I got this, and it's like that. I also courtesy to STEM 30 because they. Can we talk on the moon? I am skipping this because I don't have that bell jar experiment. I planned that bell jar experiment. Moon's gravity also, I asked for that compound pendulum. Actually, usually a pendulum bob has nothing to do with the period, but still we can plan in such a way that using a pulley with a counterweight, we can create a gravity, less gravity situation, because root over L by G. So if gravity is less, then period will be longer. Weight on moon is similar. Now moon drop. I connect it with our same primitive experiment, that is lazy tube experiment. With a metal piece, you have to count the time only. 1, 2, 3. Then you start counting. Then 1, 2, 3. Within 3, it is coming down. Now this magnet Vishwal has given to me, so thanks to Vishwal. Okay. Now I am dropping it. Okay. 1, 2, 3. Almost 6, almost double, more than double. So it's like that. Jumping on moon, is not very rather enjoyable, like jumping on trampoline, like. But you will coming down slow. Mind it. Once you jump, you will come down slow. This kind of experiment already they have done, because there were several Apollo missions between 1969 to 72, but after 72 there was no moon mission. Escape velocity is a decisive thing that I planned in such a way. Here I need one volunteer. I have one ping pong ball. This is moon. I have one metal ball, heavy metal ball. It is Earth. More than 80 times, I think. I have a few marbles. First you place the ping pong ball on this gravity curve on the middle. Let us check. You throw it. Okay. With some pressure you throw it. It is almost. Oh, it is escape velocity. Okay. थोड़ा दीजिए. हाँ. Then we'll place this heavy metal ball. Now we start. So see, there is a deep curvature, gravity curvature. Since the earth is heavy, so escape velocity is more. So if for a heavier body, escape velocity is more, and for a lighter body, escape velocity is less. Now I am going to show you a glimpse of moon soil. We have designed, say many astronauts have reported that moon soil is super dry and it's toxic in nature. Though it has already wet, but see, I have designed this moon soil, and now I am doing some experiment with magnet. See, for a moon soil, this kind of moon soil has some magnetic property because there are some minerals suspended there on this top of the soil. So this is a super dry, and it is called legolith. And contrary to that earth soil is with moisture. You can see earth soil having porosity like that. It's soft in nature. There are a lot of bombardment on moon soil. With different types of asteroid, small, big. Let us do some bombardment. Okay. Okay. It has become wet. Already it draws some moisture. That's why it is returning that. But it should not. It's like that. Impact crater I have already shown. That for epicycloid path, I need at least 2 volunteers. Binoy ji को दीजिए ना, Binoy ji आना चाहते हैं, आप आना नहीं देते. So you have what you have to do, हैं? चलिए, हाँ उनको अर्थ बना देता है ना, सान बना देता है ना, आइए ना. But it's a difficult job. क्योंकि epicycle is going to be a bit difficult. Binoy ji, you have to stand here as sun. You are sun, like that. And Rakesh ji will be the earth, moving around like that, and you have to do like that. Circling every time you have to change your position. Let me put. And your job is the toughest job. You have to follow. You slowly go. चलिए धीरे धीरे चलिए आप और ये थोड़ा जल्दी चलेगा. See that. What is the type of motion he is executing actually? ये छोटा हो गया आपका देखिए. बहुत पास आ रहा है मून. It is very difficult to follow. This is the epicycle. Epicycloid path, that is moon is. Okay, like that. And thank you very much, Binoy ji, Rakesh ji, and Jogesh ji. And Earth Moon barycenter is another interesting aspect. I don't know whether this will work. This you can check. First you check, someone check from the visitor that this is a very lightweight, this is moon, and this is a heavyweight, rather you please check. Let us check what happens first, then we will discuss that barycenter. See, that middle one also wobbling a bit. Okay. See, that moon is moving and that earth is also wobbling a bit. That's the theory of barycenter. It is quite different from that concept of that center of mass. It's like that. Actually, our barycenter, moon earth system barycenter is situated within our earth. That's why moon, we always think that moon is moving around earth, but actually it is not. Actually, earth is also moving. So, in a bigger reference frame, it will be more predominant, rather more prominent, this thing. Because of this smaller scale, this is not properly happening. Obbling is there, but it is not that way happening. So, here I am closing because we have to celebrate a birthday, but I don't have that flameless things. Let me close here. Thank you very much. Okay. Within 15 minutes.
Thank you very much, sir, for a really nice presentation. For the last session of the day, we have Ms. Sangeeta Ray, who is an education officer at NCSM headquarters, Kolkata. Her topic for the day is colloids. Welcome, ma'am.
How can I go to back? This is back, this is front.
Forward, backward.
Backward, forward.
This is laser. Center laser.
Okay.
So
It is laser.
laser.
Forward, backward. Okay.
Okay, welcome to my show, and good afternoon to all of you. My topic is science show on colloids in action. You have seen sometime before heart in action, and this is colloids in action. So what is colloid? Colloid is a substance. It is not a substance like an element, not a compound, it is a mixture, okay? So let me make some mixture. Colloid term is actually derived from cola plus edos. Cola meaning glue and edos meaning light. So it is a glue-like substance, and let me make some mixtures. I have three different solids. One is food colored, it is in powder form, and other is turmeric powder, and another is, third one is starch powder. So I am mixing this one by one. Some starch powder is added in the third beaker of water. I have taken water. I am starting this solution so that it can be mixed properly. Now see these three solution, actually mixtures. This one is food color solution, this one is starch solution, and this one is turmeric solution. Solution can be classified, mixture can be classified in three different types. One is true solution, second is colloids, and third one is suspension. So first I am seeing these three solution and categorize them by its appearance. See, it is a homogeneous mixture, means it is uniformly distributed, evenly distributed. The food color powder is evenly distributed in the water. This one turmeric mixture, you can see there are some deposition. So turmeric is not dissolved in water, and it can be known as suspension. And the in between it, this may be called a uniform solution, but I am not sure. This is starch solution, and I am disclosing the fact that it is colloid. It is actually colloid. It has the property of in between of this solution, these two solution, mixture actually. So I can distinguish this true solution and this starch solution from each other by a very classical experiment that is known as Tyndall effect. So please see carefully. I have one laser pointer, and see that I am shining this laser pointer on this solution, true solution. No scattering is happening. And when I am shining this laser pointer on this starch solution or colloid, Tyndall effect is giving positive result. So it can be confirmed that it is a colloid. Next. There are so many properties of these three types of mixture, but I am only telling the most important property, that size of particle is less than 1 in case of true solution. In colloid solution, the size of the particle is between 1 nanometer to 100 nanometer, and in case of suspension, the particle size is greater than 100 nanometer. Now see, ordinary filter paper, when we take ordinary filter paper, I have no filter paper, but it has been seen that true solution can pass through the ordinary filter paper. Colloid solution is also passed through ordinary filter paper, but suspension can not pass through because it is deposited, you can see. So there is one phenomena which is known as dialysis of colloid. Through this process, we can differentiate the true solution and a colloid solution, because this is completely different type. But these two mixture or solution can be said. This has some same appearances. So I am showing some dialysis of colloid experiment. So I am taking some water. I have one cellophane paper packet, and this cellophane paper is actually a semi-permeable membrane. Here you can see animal membranes or cellophanes are semi-permeable membrane. So I am taking some starch solution. I am sealing the packet, then I am tying up the other end of the packet. And I am pouring this cellophane packet into the water. Now, some iodine is added to the water outside the packet. Iodine is a true solution, and starch solution is colloid. So after some time, this experiment will give its proper result. So we shall observe what will happen. Actually, you know that when starch and iodine mix, what will happen? Yes, black blue color is formed. Its brown color is converted into black blue color. So after some time, we shall see what will happen. Is there any change in color? Next, I want to show you some home decor, to prepare some home decor, or it can be used as toy for children. I have taken some water with food color and I am adding some soybean oil to it. Actually, water and oil cannot be mixed because in the next experiment, I am showing you water is a polar substance and oil is a non-polar substance. So, these two substances cannot be mixed. You see, this portion is oil and this portion is water. Now, I am adding a effervescent medicine, effervescent tablet, that is Mucinex tablet. This tablet will form a huge carbon dioxide bubbles. My colleague has already shown this demonstration in some another way, and see, a lava lamp is called this, is known as this experiment. Some lava is going upward, it appears like that. Actually, I want to show this experiment for know that, can you tell me, among these materials, what is the colloid? Which one is the colloid? I have taken water. Water is compound, not mixture. And Mucinex tablet has been taken. It is a solid, but it is also a mixture. It is a compressed powder form. It is in a compressed powder form. This glass is homogeneous mixture because uniform. The true solution is food color. I have taken food color, so it is not a colloid. Remaining one is vegetable oil or soybean oil. See, this vegetable oil, some adulteration is done there, I think. So it is not showing the Tyndall effect, the positive result. Okay, actually it should be shown the positive result in the Tyndall effect. Other vegetable oil, mostly soybean oil, shows the Tyndall effect. I have done it at our center and give the positive result. Now, I am going to the next experiment. Actually, this is the colloid, okay? And this is the type of emulsion. Actually, fat molecules, triglyceride molecules are dispersed in the aqueous solution in presence of phospholipid. This is a surface active reagent. So oil and water cannot be mixed, but in presence of phospholipid, they can be mixed, and it forms an emulsion. This is emulsion is a type of colloid, and in case of dispersed phase is liquid and dispersion medium is also liquid. These are dispersed phase and dispersion medium, both are components of colloids. So when both of two are liquid, then it is known as emulsion. So this experiment is over. I am going to another one. See, I have a very useful material, that is Colgate. It is known as Colgate gel. Why it is called gel? Because gel is a colloid, a type of colloid. When the dispersed phase, which is dispersed in a continuous medium, in case of this starch solution, starch is dispersed phase and the water is dispersed medium. You can see some starch is deposited here. So this is not a uniform solution or true solution. I am actually more starch is added, so some starch is deposited here. So this is a salt type colloid, because the dispersed phase is solid and dispersion medium is liquid. But in case of gel, the opposite is happen. In this case, dispersed phase is liquid and dispersion phase is dispersion medium is liquid. So I am taking some gel toothpaste inside this conical flask. Every day we using this material, and with the help of toothbrush we form a lot of lather or foam, and it is used for washing our teeth. So why I am telling about foam? Because foam is also a type of colloid. In case of foam, the dispersed phase is air and dispersion medium is liquid. So I am taking some hot water to mix this gel toothpaste. As my topic is colloid, so I want to form some foam from this gel. But do you expect that I am taking some toothbrush and in front of you? No, no, no. I am doing in some different manner. So I have also some baking soda that you have used. Can you see this? Okay. Okay. Some food color is added for better visibility. Now I am adding some vinegar. See. So you can understand that in this case, through this classical acid-base solution experiment, carbon dioxide gas is formed, and carbon dioxide gas is dispersed phase, and this liquid aqueous toothpaste gel is dispersed medium. So by mixing this carbon dioxide gas with this water and toothpaste, the foam is formed. And this is also, foam is also a type of colloid. Now, see, I think we should add some more iodine I am putting here. Otherwise, this experiment will take much more time, and the time limitation is there. See whether I can show you the result or not. Now, see, some water and oil has been taken here. This cannot be mixed completely, but in presence of soap, these are, the water is polar and the oil is non-polar. But in presence of soap, dishwash I am using, you see what will happen. See, this mixture has some stability now, because the soap is a surface active reagent. It has a hydrophobic and hydrophilic ends. Hydrophobic ends will want to attach to that oil, and the hydrophilic ends want to attach with water. So, this soap can bind this both oil and water, and emulsion is formed here, and it is more stable than the earlier one. Now see, I have a centrifuge machine here. The dispersed phase and dispersion medium, the starch and water cannot be separated easily. When we use this centrifuge and spin it, I have to spin it for 5 to 6 minutes. I don't know, madam will give me the time or not. Okay, then it will be fine. It will be comfortable for me. Actually, centrifugal force is acting here, and the starch molecule are pushed towards the bottom of the container, this tube, centrifuge tube, and water remains at the top. See what will happen. आ जाइए. See, can you differentiate this starch and yes, you see. Yes, this is starch and this portion is water. So centrifuge machine can separate these two things. Thank you. Actually, I want to tell the result of this experiment because bell is ringing. Actually, actually this starch solution becomes dark blue in color because this true solution can pass through this, the particles of this true solution, the size of it is less than 1 nanometer. So it can pass through this semi-permeable membrane, but the starch solution colloid is cannot pass through this packet or cellophane paper. So we can separate this true solution and colloid from each other using this cellophane paper like thing or semi-permeable membrane. In case of our kidney, it is happen that kidney membrane is semi-permeable membrane, blood is a colloid, and electrolytes that are waste product, those things are true solution. So semi-permeable membrane can allow to pass that true solution electrolytes, and electrolytes can pass through it, and waste will go out, and the blood remains in the kidney, in the pure blood. This is known as, that is why actually dialysis term has been formed. So I do not show you that experiment what has been shown to you by our colleague Tarun sir, that fog formation. Fog is also a natural colloid. In that case, it is aerosol type of colloid. In that case, water is the dispersed medium, and dispersed phase, water is dispersed phase, and air is dispersed medium. So you see that so many experiments are doing with the help of colloids. This world is full of colloids, so enjoy the world of colloid. Be healthy, happy. Come again to VITM, and thank you for your attention. Thank you.
Yeah, a very big round of applause for the madam, and it was really a wonderful experiment session of chemistry, and we thank everybody for patient listening, and in this, today we are closing this session, and tomorrow we will meet again as per the schedule. Thank you all. Thank you.